Okay, we're going to do some more operations with radical expressions. So lesson 7.5, copy down the title and the essential question. You can hit pause. A couple of rules that you'll want to write down. We can take any nth root and we can separate them if it's through multiplication or division. And then a simplified radical expression, the index n is the smallest possible. The radicand contains no factors. And the radicand contains no fractions, and no radicals appear in the denominator. So again, copy all of that information down that's highlighted. And let's take a look at our first problem. So we said at the beginning that you can separate square roots. Okay, square root of 25, that's just 5. The square root of a to the 4th. Remember that there's an imaginary 2 there, and we take and we divide the exponent by 2 then. So this becomes a squared. Now if we did that same thing with the 9 divided by 2 is not going to come out even. So what we're going to do is split apart the square root of b to the 9th. Okay, I'm going to count down from b to the 9th to find something I can take the square root of. I can't do b to the 9th, but could I do b to the 8th? And I could. So I'm going to put b to the 8th there, but I need one more b in this spot because those two together equal b to the 9th. Now there's this 2 here, and really it's 8 divided by 2, so it becomes b to the 4th and the square root of b. Okay, and then we check even, even, odd. We started with even, but we ended even, so it doesn't matter. It only matters if we end odd. Okay, next problem. We can do the same thing with cubic roots. So copy down this problem, and then let's split them apart. Cubic root of 125, cubic root of m raised to the 30th, and the cubic root of p to the 20th. All right, remember to type in 125 as 125 raised to the 1/3 power. And you don't use the square root button when we're doing it this way. And you should get an answer of 5. The 3 comes and is divided by over here, so it's going to be m to the 10th. And again, the p is not going to work out. So I'm going to split it apart, 2 cubic roots. Okay, 20 doesn't work, and remember it has to be divisible by 3. So 20 doesn't work. Does 19 work? No. Does 18 work? Yes. So we're going to do p to the 18th. So how many more p's do I need in the second one? So it totals 20. I'm going to need 2 more p's. Okay, so then I take 18 divided by 3, and I get p to the 6th. And I can't do anything with it. P squared in the cubic root. And that's our answer. Do we need absolute value bars? Did it start even? No. So we don't have to worry about that. Okay, this one we can do the cubic root and pull them apart as well. Okay, this time if you type in the cubic root of 192, which would be 192 raised to the 1/3, it's going to come out as a decimal. So that's not going to work. So let's just review what we would have done to split apart a number like square root of 20. So this is just reviewing back before. We would have split it apart into 4 and 5. Square root of 4 becomes 2. Could I have done square root of 2, square root of 10, because they both make 20? Would that have helped me? Could I take the square root of 2? No. Can I take the square root of 10? No, neither of those come out nice. So even though we can split it up this way, it's not going to help us at all. We had to find a number that we could actually take the square root of. Well, in this case, we're going to have to find a number that we can take the cubic root of. So let's write out a list of cubic numbers. And so what we can do is do 1 times 1 times 1, which is 1. 2 times 2 times 2, which is 8. 3 times 3 times 3, which is 27. 4 times 4 times 4, hold up just a second here. That's 64. And in your in your calculator, you can continue typing it in, but it's 125, 216, 343, 512, 729, 1000, and that list just keeps going on. You just do 11 cubed and so on to continue getting the list. Okay, so now we figure out how can we split apart 192. Which number on this list down below will be divided by it evenly? And the answer is 64. 64 times 3 makes 192. And we can take the cubic root of 64. It is 4. Then I'm going to put the cubic root numbers at the end. Okay, let's do the m. I can't do 3 divided by 13. I'm going to have to split it apart. So counting down from 13, I can't do 13, but I could do 12. And so I just need one more m right there. So now I can bring this 3 and divide it. So I get m raised to the 4th power. And I have to put this other m inside. And this one, I can just divide that by 3. And I get p raised to the 7th. Okay, even, even, odd. Check for absolute values. It starts odd, so I don't even have to worry about it. This is our answer. Next problem. The square root of y to the 8th over x to the 7th. Okay, so for this one, we can just split it apart. All right, and let's break the top down. It's just going to be y to the 4th. The bottom, though, I'm going to have to think about that as x to the 6th, and then another x. So this becomes x to the 3rd with the square root of x. Now, we wrote also in the notes at the beginning that you cannot have a radical in the denominator. So we can't have that square root in the bottom. So how am I going to get rid of that? I'm going to multiply the top and the bottom by square root of x, and you'll see how that'll come out. That's called rationalizing the denominator. You end up with y to the 4th, square root of x, over these two here become the square root of x squared. Well, the square root of x squared is just x, and if we bring down the x cubed, it becomes x to the 4th. All right, now do I need absolute value bars? Starts even, but it ends even. So it's even, even, odd. We need absolute value bars, so we're okay on that one. Okay, let's try doing this with cubic roots. So we would take the cubic root of 2, cubic root of 9, and the cubic root of x. Well, we can't take the cubic root of either of those. So what I'm going to have to do is multiply the top and the bottom to get numbers that we can take the cubic root of. Okay, so you need to think about at the end what we want it to be. Well, really, a 9 is 3 times 3, so if I have another 3 with it, it would make 27. So I need another 3. Well, and I need to have at least 3 x's to take the cubic root of, and I have 1, so I need 2 more. So I have to do the same on top and bottom. And I forgot the cubic root right here. Okay, the top becomes the cubic root of 6x squared. Okay, I can't do anything with the top. But the bottom, the cubic root of 27 will be 3. The cubic root of x cubed is x. Do I need absolute value bars? Started odd, so no, I do not. That's our answer. Okay, another problem that we could see is where we multiply these together. So we'll multiply 5 by any other numbers that are on the outside, but there aren't any. So I'm going to put just 5 out in front. But I can multiply the cubic root numbers together. So 100 times 10 is going to be 1,000, and I will have a cubed. Okay, 1,000 actually was on our list, and if you don't remember it, it's 1,000 raised to the 1/3. That should come out as just 10. So 5 times 10, and then the cubic root of a cubed is just going to be A. So the answer here is 50A. Do we need absolute value bars? It's an odd root, so we do not. And how about this problem? We can add and subtract polynomials. Okay, so to do this one, it's just square roots. So we go back to the method that we used before, and we're going to split them apart. 45 can be split up as 9 times 5. So 3 times 3 square root of 5, or 9 square root of 5. Okay, 80. Be careful on 80, because a common thing people want to take out is 4, but you can actually go higher. You can go with 16 and 5. 16 becomes 4, so then that becomes 20 square root of 5. And then the last one, 20, how can we split that apart? 4 and 5. So 4 times 2 square root of 5, or 8 square root of 5. Okay, because all of them are square roots of 5, we can combine them together by just taking 9 minus 20 plus 8. And that's going to come out to be negative 3 square root of 5. There's our answer for that problem. All right, we also might see a problem where we need to FOIL. So first to be careful, the outside numbers get multiplied together. And here, the square root numbers get multiplied together. So minus 2 square root of 9. Inside would be 9 square root of 5. And the last two is negative 3 square root of 15. Okay, is there anything we can simplify? I see this one right here. Negative 2 times 3, so negative 6. And I don't see anything else I can simplify. So we just write it out as one long expression. Nothing can be reduced. And so that is our answer. One last problem for us to do. Okay, so you can read through this problem, but really all we have to do is rationalize the denominator. And rationalizing the denominator, we use the conjugate, which is the same as the denominator, but we use addition. Okay, the top we could just multiply through. A squared, distribute that in, square root of 2 plus a squared. The bottom we're going to need to FOIL out. A squared, square root of 2 squared. Outside, plus a squared, square root of 2. Inside, minus a squared, square root of 2. Last two is minus a squared. When you use a conjugate, the outside and inside will always match up. And so this part will actually just become 2a squared minus a squared, which really just becomes, that's like a 1 there, 1a squared. So this is a squared. And now I notice they all have an a squared, so we can cancel an a squared out of every term. We're left with the square root of 2 plus 1. That's our answer. Okay, that is the end of lesson 7.5.